Hello, this is John from caveofprogramming.com. In this tutorial in C++ for complete beginners, we're going to take a look at headers and prototypes. So we've seen that you can define a function like this. Let's put it above the main function here, and let's type void do something, just to give it a name, and we'll output cout hello in there. So this is just a normal function with just one line of code in it, and in the main function here we can call that function. Here we've defined it, we've implemented it, and now we can call it to actually make it run. Let's type do something, and we can call it as many times as we want. In fact, let's call it twice, just for no reason. And if I run this now, we should see a couple of hellos there. So I've invoked this function twice, I've called it twice, so it's run twice. But we've seen that if you were to define this function below main like this, if we now try to build the project, it doesn't work because the compiler reads this function down line by line from the top. And when it gets to here, it hasn't seen this. Now that's quite inconvenient, and we can actually fix this by putting what we call the prototype of the function above main. So what that looks like is, here we see that the line of the function that defines what parameters it accepts, none in this case, and what it returns, which is nothing in this case. That information is all contained in this bit here, and that's all the compiler really needs to know in order to allow you to call the function. So what we can do is, above main, we can type void do something round brackets. So start defining the function just as normal, but then stop at this point where you would normally open the curly brackets, just put a semicolon instead. And this bit of the function is called the prototype, and it shows how the function operates. It shows what it returns and what it accepts, which is nothing in both cases. With that information, the compiler can then say, okay, you're allowed to call that function, and I trust you that the implementation will be provided somewhere else. In this case, the implementation is down here. So this line, by adding a prototype here, we can this will actually make this main function compile now. So let's do that. Let's go to build project, and we see that now the errors go away, so I can now run this. Now as we're going to see later on, it's common to define functions in separate files altogether. In fact, later on we're going to see that you often bundle functions together with data in what we call a class, but we haven't seen that yet. And groups of related functions basically are typically put in their own file. So what you need is to have all the prototypes of related functions in some file, which you can then include in this file. So let's take a look at a simple example of that in this tutorial, just to get us started with this. What I'm going to do is let's click the source folder here in the project, right click it and go to new, and I'll go to new other. And if we scroll down here under the C++ section, we've got header file. Let's select that, and I'm going to call this, I'll just give this a name, I'll call it utils.h. So the kind of file that I'm defining here should end with a .h, and we'll click finish. And notice we've got some stuff in here that has automatically been added by Eclipse. So the file that we're actually typing in here, you'll notice, ends in .cpp. It's just a text file. And this new kind of file that I'm showing you here ends in .h, but again, it's just a text file. What we can now do is take this void do something, cut it out from here, go to utils.h and paste it in. Then I can save that. So I'm actually pasting it. You'll see there are lines here. There's a line that says define, and there's a line that says endif, and I'm pasting it between these two lines. So now we go back to prototypes and includes.h, And at the top of the file here, let's put it below the line that says include iostream, but above the line that says using namespace standard. Let's put in another include. I'm going to type hash, or I think this is called a £sign in America, include. And then in double quotes, I'm going to put utils.h, and I'm going to save that, build the project, and now you'll notice that it runs as before, so I can run it and it says hello. So the way this works is that this command actually says to get this file here and literally paste it in to this file here in a sort of copy of the file before it's compiled. So what the compiler will actually see is this file, but where you see include, something called a preprocessor will have gone away and found the files mentioned here and literally pasted them in to this file here. So what this actually sees now, what the compiler actually sees, will, instead of this line, will be this same file, but with this line in it. So there are a few things to mention here. One is that I've used double quotes here, but here the include has angle brackets around it. This is also a file just called iostream. Used to be called iostream.h, and on some platforms it still is. But for various compilers, it's just been renamed to miss off the .h, just because I suppose it looks nicer, basically. The angle brackets, well, there's no absolutely certain and consistent meaning to the difference between double quotes for an include and angle brackets. But in general, the kind of idea is that angle brackets refer to a file that's in a standard location which your compiler will know about. So this is going to be in some special location on your disk that the compiler will automatically look at. Double quotes are usually used for files that are actually included in your project, like this utils.h that I just defined. So this file is in some standard location. This one in double quotes instead of angle brackets is actually in my project. But in practice, the angle brackets and double quotes may well be interchangeable for your compiler. It actually doesn't matter too much a lot of the time. But nevertheless, it's not bad to stick to the convention, since at least the double quotes clue you in that this is a file you've defined yourself in your project. You'll also notice that in utils.h here, we've got these if not def, define and endif statements. Now the way this works is when your program is built, there are several stages to it, and the very first stage is that something called the preprocessor runs, and the preprocessor looks for statements beginning with these hash symbols, and it follows whatever commands you specify in these kind of hash symbols. And the most common hash preprocessor, we call it a preprocessor directive. The most common preprocessor directive are these include directives here. So the preprocessor will run and it will process the files somehow, in this case replacing these lines with the contents of the specified files. And that's why these lines don't end in semicolons, because they're not C++ statements. They're not statements in the C++ language to the C++ compiler. They're actually statements to a kind of separate bit of software that runs called the preprocessor, which will run before the actual compilation, the actual transformation of the text file into binary code. Before that occurs, before that is actually happens, the preprocessor runs. And here, these are more preprocessor commands. So again, they don't end in semicolons. And this is just saying define this symbol. In other words, kind of memorize this symbol. And this symbol, it could be anything basically. In this case, it's utils _h_. That's purely to create some sort of unique symbol for this file. It could be, anything at all really. But this is kind of a convention that you use the name of the file _h because it's utils.h, and then it's added another underscore on the end of it just to make it even more unique really. So it's saying define this symbol. In other words, take note of this symbol. That's an instruction to the preprocessor. Here it's saying if not def. So if this symbol is not defined, then define it and do all this stuff, and then end if. And what this is actually aimed at doing is, often in your program you'll end up including the same file into multiple different files, which will all be combined together when your program is actually compiled. And you can end up with multiple includes for the same include file, and that will cause you problems if you had that. And this is just a way of ensuring that the contents of this file cannot be included twice, because the preprocessor runs, it says, okay, the first time, if this symbol is not defined, define it, do all this, and that's then the end of the if. If this symbol is defined, it says, okay, I see this symbol is already defined, and we're only supposed to be doing all this. If it's not defined, if not defined. So therefore, if this symbol is defined, when the utils.h is included for the second time, then we will not do any of this. We only do this if it's not defined. Well, don't worry if that loses you a bit. We're going to be getting used to this, because we're going to be seeing more of it. But the thing to do for this tutorial is just practice. First of all, define a function and just call it in your main function. And then try moving it below your main function, and try putting the prototype above so that your program then compiles, as I did earlier in this video. And if you like, you can take one of the projects from a previous tutorial where we define multiple functions, and then move the definitions of them below your main function, and then add the prototypes up here to get it to compile. See if you can get that to work. And then finally, move the prototypes to their own header file. And if your IDE doesn't create these if not def things, then define them yourself. So it's not as important at this stage to really thoroughly understand what these actually do as it is to get used to typing them. In fact, you will probably never really need to use these preprocessor directives a whole lot. You'll only probably need to use them in this context. So if you can memorize them and you just have a rough idea of what they're there for, namely to prevent multiple includes of the same header file, then that's good enough. So try doing what I just did basically. Try using a header in your program. And later on we're going to be using headers a lot more, and we're going to be using multiple CPP files as well to separate out our code into multiple files, which is going to make it a lot easier to work with. So I'll leave it there for this tutorial. There's more to be said about this, and we may well cover this a bit more next time, but I think that's enough for now. So until next time, happy coding.